So this is the part where we will do the flip simulation, and we will give it particle surface, and this is the result that we will end up with, hopefully. It was too many trials just to come up with the results to create this wave. It was the initial intention that the bridge will fall, and we have the water splashes from the pool and to the surface. So this is the particle. Let me stop this one and go here. So this is what the particle colored per velocity. So we have the main wave here being created by the bridge when the bridge collapsed in the previous video. So we have the wave splashing. Okay, so let's see how we go. We created this one. So previously we created the collapsing bridge. As you can see, and fall down. Okay, after that I wanted to create the volume here that will represent the pool. So the shelf tool, when you go to the particle fluid, you can create flip tank or sculpted particle fluid. I went there, but I was not happy with the result, because you have the surface, I call it the top, I transform it down a little bit, and this is the other volume, and the surface being extruded, increase a little bit, and we come up with the Boolean fluid, as you can see. Here, see, so I was not happy with the geometry, but because it is a box, so I created a box that's roughly or a little bit smaller than the pool. I give it a VDB. Give it a second. Let me remove this one, and I created point from volume. So the point from volume will add all these tiny points, and I need two things. I need the particles. You can see here I need the particles. Also I created a VDB that will represent the surface. These two parameters is essential for the narrow band, these two. Okay, so I took them both, I went it outside, I created an Autodope network. Just give it a second. Till it cook. Okay, so here I will decrease the resolution so it can be playable. Okay, now it's responding. I make it 0.07. Let's make it 2, so it can respond. Okay, let's give it a second. Rasterizing. Okay, so what we have here, we have the static object, that's the floor and the pool, and this is the bridge, and I make it use deforming geometry, and I included the VDB for both. Okay, now for the fluid, initially for the data I used narrow band, and I pointed the display and the surface. Okay, and this is the guide, physical, collision, nothing here, but here I think in the physical it's the same, but here I decrease the bouncing for the floor because I don't want it to be bouncy. Now for the flip solver itself, I keep the same step. If you increase the steps, it will be more accurate. Behavior nothing, receding I kept it for the narrow water because here I activated and I increase it to 4 because the parts are moving inside. Initially it will be 3. Okay, and separation, no separation, droplet identity, it will look nicer if I put this one, and no vorticity because my camera is from far away, it will not show. Volume motion, this is the limit. I didn't use water line because I wanted to splash and not to refill. Collision, if you increase the velocity scale, so the water will react according to this multiplier and the splash will be bigger, and it will look nice, but I ended up with keeping the default value, and here nothing changed. So if I play it through, it will take a while. So Ctrl G, I went here and I imported here. Interior, I didn't use the interior because I didn't do a shot inside. Okay, so I went here. Inside here I imported the geometry, the fluid, just give cancel because I save it after being compressed. Okay, so here this is created by the shelf tool. It will compress the fluid, and I save it on the disk and add it here. Okay, so this is the, you will see the boxes represent the voxel for each particle. So it's loading from the disk now. So let's go to the, so let's go to for one frame and make it load. So you see the voxel. Then what I did, I give it a surface. The surface I used the shift. You can use VDB also. I was trying to use VDB, but this one is cool. You have too many argument to play with and attribute to change. So the surfacing part separation, keep it 0.2 because I don't want very much detail. Voxel size I went down to 75, and the influence scale 75, and the droplet scale is 0.5. No filtering, no region, and then I cache it and take a frame in the middle and see, because with flip fluid you need to cache at the beginning. You need to sim in a very small scale, not that high res, so you can test your flip, because I did it like 4 or 5 times just to come up with this like semi-acceptable result. Okay, and after that I move to white water. Let's have another look. This one I can put them side by side. This one here, this one here. This is bigger now. Let's make it smaller, like this. Okay, so next see you in the white water section, because I try to make it straightforward, simple, direct to the effect. Hopefully you like it. Thank you very much.